more abstract and deeper question for you. If we do find evidence that life exists or existed on Mars, that means two planets in the same solar system have life. What are the implications of that on a broader scale in terms of Fermi's paradox?
Well, they say that the universe is full of life. If it happened twice, right here in our own little solar system, it would say that Earth is not some sort of cosmic fluke, and that the universe is full of life. And then you could go stew on Fermi's paradox. Yeah, I'm just interested in microbial life. I would conclude that microbial life, and life itself, not intelligence, but life, is widespread. We have found two examples of life. We haven't found two examples of intelligence. Right? So I think it's that at least in terms of Fermi's paradox, it's not easy to go from life, necessarily to go from life to intelligence.
And you would argue that intelligence confers an evolutionary advantage.
You could. It's not obvious it does.
But obviously in the case of Mars, it didn't stay habitable long enough.
Maybe.
Or maybe it did. Maybe it just didn't work out that way. But
yeah, I think intelligence is overrated as an evolutionary adaptation. But you know, I don't think we know. Question here.
Is it possible? I mean, if there's stuff crash landing on Mars and things like that, isn't it possible that some of this Earth life would end up contaminating parts of Mars without us knowing exactly where everything was?
It's unlikely because Mars is an incredibly hostile environment. Any organism exposed to the environment, released, blown in the wind, will be killed in a matter of minutes or seconds from the UV light. On Earth, UV light from the sun from 300 nanometers and below is blocked by oxygen and ozone. Ozone plays a bit role, but the real blocker of UV light from the sun is oxygen. Probably worked with the so-called vacuum UV.
Well, but what if it ends up under a rock or something?
Yeah, if it ends up under rock, then it's a problem. So
we just burned the landing site.
Right. So landing sites where there's been disturbance, you've got to worry about the soil in the immediate vicinity. But what you don't have to worry about is anything getting blown around and spread globally. Right? That would make it very hard. You don't have to worry about anything growing. So you don't have to worry about spreading, and you don't have to worry about growing, which makes cleanup a lot easier. It's like the rabbits in Antarctica versus the rabbits in Australia. They don't get far and they don't grow. And that was the problem with Australia. The rabbits spread everywhere and they grew. So it's an important distinction.
Is it possible with the one that crashed that you didn't know what happened to it, that it could be harboring life that you can't clean up?
Well, the ones that crashed, like the Polar Lander, we know where they crashed. We know where they are. In fact, a couple of summers ago, I had a summer student go through the photographs and find the crash sites for all of them. And we estimate that that one fell from a couple hundred meters. So it made a crater, but not a very big one. It's probably a pile of junk on the surface. So far, we haven't crashed into Mars fast enough to really penetrate into the subsurface and really make a mess. Doesn't mean we can't do that someday. We might, but the point is to try to avoid that. And so the idea is to set a realistic goal in what we're trying to do, which is avoid anything that's irreversible.
So that's a position on Mars to avoid biological
Irreversible
biological harm. What about the moon?
Oh, I don't care about the moon.
Terraform that for as much as you want.
Well, you can't terraform the moon. It doesn't have the resources and it doesn't have the gravity, and it's too close anyway. So, I'm a big fan of a moon base. I think it's very useful to have a moon base there, to have a base on the moon, but it doesn't really have a future. Remember I said about Mars, the two big questions were, does it have a past, a biological past, and does it have a biological future? And who is in that biological future? Neither of those questions make any sense on the moon, in my view. There's other questions, like what's this rock made out of, which you can ask on the moon, and those are interesting questions, and you can do PhD theses on them. But they're not the big questions of life in the universe and the future of life and the future of everything. Those questions really, the only place in our solar system where those questions, at least as we understand it, come to bear on Mars.
On Titan.
Enceladus and Europa are starting to come into their own too, Titan, but not the moon, that's for sure. So it's scientifically interesting, but not at the same level as Mars. But it's so close that it's a logical place for the next target, for the first base.
What about Titan for a target for manned exploration? Because it's got like an atmosphere and a lot less gravity, and wouldn't it just be a lot easier to land something on Titan because all it needs to have is a parachute instead of
Yeah, it's pretty.
all this other complicated stuff?
Yeah, it's easy to land on Titan.
Yeah.
Yeah, but the question is, what would you do there? The real question is, why would you want to go there, and what would you do there? And why would you send people as opposed to just robots? So if you look at the moon, why would you send people to the moon? Well, because it's fairly easy to work around on the moon, and it's close enough that it's easy to do, and there's enough interesting science to do there, and we'll learn how to operate on another surface, on another world, by being on the moon. So those are the logic for going to the moon. The logic for going to Mars and sending humans to Mars is to ask the question, is this a place where humans can live and work, that we can make another biologically rich environment? I don't think you can imagine that on Titan. It's hard to see what the rationale is for sending humans to Titan. And nobody's really, it's obviously a lot harder because it's so far.
Yeah.
The trip times are long, etc. But no one's really come up with a good rationale for why would you set up a human base in Titan as opposed to just sending robots. But your point is still correct that it's one of the best places in the solar system to work. So easy. Gravity's low, the atmosphere's thick. You can fly there. We're working on a mission design for an airplane on Titan. And because the gravity's low and the air is thick, and the rotation is slow, you can fly faster than the sun. So you can always be at noon with the sun right above you. So you can, and always have Earth. You can fly faster than the Terminator goes around the world. Titan takes 16 days to rotate. So it's really a cool mission for robots. But I don't see the logic for sending humans.
Well, that raises a broader question of human versus robotic exploration. And from everything you've told us, I mean, yes, the probes that landed on Mars had done some good research, but you discovered, oh, perchlorate, oh, our other instrument doesn't work now. And we have to wait years before we can send another machine up, whereas humans are adaptable enough to repair equipment, try different experiments, and so on.
But I resist the notion that we justify human exploration because they're good at doing science. I justify human exploration because it's human. And science is a tool that we use, not a tool, not something we serve. And this was brought home to me. I was in a meeting at Stanford, a big policy decision meeting, and Len Fisk, the former associate administrator of NASA, stood up and said, well, it isn't clear that humans are the best tool for doing science on Mars. I said, wait, I'm not a tool, right? Humans are ends in themselves. The human experience is the end, not the tool. Science is a tool, and it's one of the tools we use to enrich the human experience. It's not the only tool we use. And right now, it's the tool we're using primarily in exploring space. But it's not even clear that it will be the most powerful tool that we will use to integrate space into the human experience. It's not clear. It may be. Depends. We don't know enough about space. We don't know enough about Mars to know how it will integrate into the human experience. And so I would argue that really science that we're doing in the solar system is in service of the broader human experience, whatever that will turn out to be. And that's why we send humans, in service of this broader human experience, which we still don't know what that is. We're asking the question. One of the two questions about Mars is, what is its future? Well, that future will depend on human choice. If we find life, do we choose to resurrect